So we talked about likelihood yesterday, and that's part of probability. And then the other part of probability is figuring out what are the chances that it's going to happen. Which you've basically been doing that with the four corners exercise. So there's two types of probability. You've got experimental probability and you've got theoretical probability. Theoretical, have you ever heard anybody say theoretically speaking? Theoretical basically means we're going to pretend. We're not going to actually do the activity, the experiment. We're just going to think about it. Think about what could happen. So theoretical is more about thinking and not doing. Okay, theoretical is about thinking about the problem, not doing it. Experimental probability is the opposite. Can you conduct an experiment? Can you carry out an experiment? Yes. Experimental probability is when we actually do it. Whatever they're talking about. If it's talking about rolling a die, they're actually going to roll the die. Okay? Not just think about rolling the die and the possibilities. They're actually going to do the experiment. Okay? That's the difference between the two. Experimental is an active doing, where theoretical, we're just thinking about doing it. Does that make sense? I'm going to give you some examples and hopefully that'll make sense here in a second. This is how we set up probability though. You put the number of times the event occurs over the total trials. So number over total. Same thing for theoretical. Number over total. So, like the banana like the four corners banana example, right? How many, if you think about, did we actually pull letters out of the banana? Like, do we put letters of the banana in a bag and mix them up and then actually pull out letters? No, we just thought about what it should be, right? Mm-hmm. And when you set up your fraction, you set it up as 3/6. So there's a total of 6 letters in the word banana, right? Mm-hmm. Really singing the song. All right, and there's 3 A's, so you did 3/6. What you did was theoretical probability. You thought about it. If we wanted to do experimental, I'd cut up the letters, put it in a bag, shake it all up, and then have you pull it out to see how many times you got A. Does that make sense?
Pull them out until you get to the last one.
If you pull it out, and you'd have to put it back in the bag. So pull it out, put it back. Pull it out, put it back.
How many times do you know you're supposed to do it?
They'll tell you. Yeah. It just depends. The more you do it, the more accurate it'll be. But if you did it 10 times and you only pulled the letter 2 times, your fraction would be 2/10. Alright, so it says, when you conduct an experiment, the experimental probability of an event is a fraction or percent. I might would highlight that. Fraction or percent. Because can't we convert, oops, y'all can't see that. Can't you convert a fraction to a percent? Yeah. Okay. So we're actually going to do some of this. Practice doing some of this. Okay, it says a table shows that the results of spending a penny 25 times. What is the experimental probability of spending heads. How many total times did they do this? 25, right? If I add this together, I get a total of 25. So your event, your probability, we're looking for the probability of spinning heads. Okay? So we're looking for the probability of heads. How many times did they spin heads? 6 times. Out of a total of, change that to a percent. It's about 24%. Now you would think it would be what? If you're spinning it, right? How many options do you have for spinning a coin? 2. How many options are head? Of those 2 are heads? 1. So theoretically, okay, we have 2 options and one of them is heads. So if I change that to a percent, that gives me 50%. This is theoretical. This is experimental. Did my experimental line up with my theoretical? No. That's when we know some kind of human error took place. Okay? Because what if he wasn't spinning it the same way every single time? Or what if it kept falling off the table? Or anything could have been happening to make this not line up. Okay? Alright, example 2. Now we're finding theoretical probability. She's just going to think about the options. Lindsay is going to draw 1 tile from a bag shown without looking. The tiles are the same size and cannot be told apart by touch. So each of the tiles have an equal chance of being chosen. What is the theoretical probability that she selects red? So if we turn the page, it says find the total number of equally likely possible outcomes in the sample space by adding. So looking at your tiles here, we printed in color. How many green? We want to know how many total tiles do we have. So how many green tiles do we have? Jonathan, you're going to come over here with me. Hush. How many green tiles do we have?
4.
Or is it 5?
Yeah.
5. Okay, how many red tiles? And how many blue tiles?
9.
Which gives us a total of how many tiles? There's a total of 20 tiles in here. So there are 20 equally likely outcomes in the sample space. Alright, how many red tiles did we say there were? There were 6 red. So how many possible outcomes? This is kind of like the back of your homework last night. How many possible outcomes are there for choosing red tiles? 6 possibilities. Is this the same equal chance as all the other tiles? No, because green only has 5 and blue has... So just looking at those numbers, which one is, if this was like a competition between the color tiles, which one would be most likely picked the most? The blue, right? Because there's 9 of them. There's more of them, right? So does the red have an equal chance to the blue? No. Alright, it says find the theoretical probability that Lindsay will select a red tile, then write the ratio as simplest form. So we want the number of over the total. So we want the number of red over the total number of tiles. So we have 6 over a total of 20. And if we were to simplify that, what is 6 over 20? 3/10, right? And if we convert that to a percent, we get. So what's the likelihood of picking red?
It's like unlikely, yeah.
Alright, this will be considered unlikely. Alright, this says it could be written as a fraction, decimal, or percent. We've pretty much done this already. We did it as a fraction. And we did it as a percent, but we didn't write it as a decimal. How do I write 3/10 as a decimal? 0.3. If you don't know, you could put in your calculator 3/10. And then just hit the double arrows, remember? And it changes it to a decimal for you. Do you remember how to do that? Are you sure you remember how to do that? Okay. Do you think you could do this?
Yeah.
It's pretty easy, right? It's just fractions, and then change your fraction to a percent, right? Alright. So it says, often the same experiment is repeated many times. Each repetition of an experiment is called a trial. We talked about that yesterday. And each result of a trial is an outcome. A set of one or more possible outcomes of the trial is an event. The sample space is the set of all possible outcomes of the experiment. So, rolling a number cube 10 times. What is the sample space? Well, what does sample space mean? Come back up here. A sample space is a set of all possible outcomes. If I'm rolling a number cube, what are all the possible outcomes? We talked about this yesterday.
1, 2, 3, 4, 5, 6.
Right, 1 through 6, right? 1, 2, 3, 4, 5, 6. All the possible answers I could get. Not hard, right?
Mm-hmm.
What is the likelihood of each outcome? Well, do any of these repeat? No, they all have one chance out of a total of what?
6.
Out of 1, 2, 3, 4, 5, 6. Okay? So, how do we figure out likelihood? We got to convert it to a percent, right? So if I have 1 out of 6 chance, gives me a percent about 17%. So what's the likelihood of that? So all of them are pretty much unlikely to happen, right? So what is the theoretical probability of rolling a 2 and then rolling a 6? Well, aren't they all going to have the same probability?
Mm-hmm.
Because they all only are there one time out of 6. So what would be the theoretical probability of rolling a 2? How many 2s do you have? Out of a total of? So what's our percent? 17%. What about rolling a 6? How many 6s are there? Out of a total of? 6 numbers. What's that as a percent? Ta-da! Can you do that? Can you think through that? Okay. We're going to come back here in a second and do this one where you're actually going to get to roll a number cube and everything with your group here in a second. But let's go ahead and turn the page. We'll come back to that in a minute. And look at the marbles. if you are choosing marbles from the jar shown and you want a blue marble, is the probability closer to 0%? Is it closer to impossible? Or is it closer to for certain? Just looking at it. It is unlikely to happen, right? If this is your jar and you're gonna try and get a blue, it's just looking at it, it's probably unlikely to happen. Okay? It's closer to 0% chance, right? Is it unlikely, likely, or not?
Is unlikely as likely
That's not.
as
correct.
not, or likely? It's asking is unlikely as not, unlikely, or likely? Holy.
Is likely as not, or likely?
I think it's like. I think the
Maybe this
second
is
one
supposed to be
likely.
equally likely.
Yeah.
This
Okay.
makes
Okay.
so much
Okay.
sense.
I think that's a typo there. Alright. Is it unlikely, likely, or equally likely? Just looking at it, what do you think?
Unlikely.
We're thinking unlikely. If we wanted to do the math behind it, how many blue marbles are there?
4.
4 out of a total of how many marbles? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I got 16.
I'm not sure.
1, 2, 1, 2.
I got 17. I got 91.
10, 11,
I got 12.
I got 16.
I got
I got 12.
There's one right here. 1, 2, 3,
Yeah, I got
4,
16.
5, 6, 7, 8, 9, 10, 11, 12 red, 4 blue. I'm going with 16.
That is
Okay? What is 4 over 16 as a percent? And where does 25% land us? Unlikely. So we were right. We did it. Y'all didn't watch Dora when you were little, did you?
I did.
Did y'all watch Dora?
I watched
Yay,
it.
we
I
did
still
it.
watch
We
it
did
because
it.
of my little cousin.
Alright, if you are choosing marbles from this jar shown and you want a red marble, is the probability likely as not, or likely? This I think is supposed to mean equally likely or likely.
Likely, I think.
Picking red,
Likely.
likely, unlikely, or equal?
Likely.
Likely. We could do the math behind it. We're going with 12 red marbles, because I say so. That's what I counted. It was 12 red marbles. Okay? Out of a total of, I'm saying 16.
Yes.
I don't know what y'all found, but I
I'm saying
found
91.
16.
I found
Okay.
a peanut butter jar.
That's great. Alright, change it to a percent.
75.
Were we right?
Yes.
Yay, we did it. Yay, we did it. Alright, what number and what percent describes the probability of a certain event? In order for it to be a certain, what does the probability have to be?
100%.
Good. Alright, certain means it's going to be 100% or 1. For it to be impossible, what is the percent of impossibility? 0% or just 0. Is this terribly hard?
Easy.
Okay. That's what y'all say now. So hopefully it stays that way. Well, tomorrow you probably won't think about this. So you'll forget
It's
about
not
it.
long like that.
Alright, Claire is playing a game where she chooses to spin one of the spinners shown. If the spinner lands on section labeled A, she wins a pair of headphones. Which spinner will give her the best chance of winning? Just looking at it, if you had to get an A to win, which one do you think you're going to pick? Who's picking spinner 1? Anybody going with spinner 1? Few of you? Who's going with spinner 2? Alright, why are we saying spinner 2, most of you?
It has more
More
chances.
more chances.
Yeah, more chances of
There's more
ace.
chances.
But they're bigger on spinner one.
But spinner 1 has more space.
More space than yours. What if you do get
Well,
on
they're
ace?
equal because they both have like.
Alright, let's see. Let's see. Alright. Total number of sections of the spinner. Spinner 1 has a total of 4 equal sections or identical sections. And spinner 2 has a total of 10 identical sections. Alright, how many sections in spinner 1 are for A? For
Spinner 1 is 1.
Oh, wait, not two.
Oh, no, it's 2.
Alright, spinner 2, how many sections are there?
That's a better case.
There's a 50-50.
Alright. Alright, what is the ratio of section labeled A to the total number of each? So for spinner 1, there's 2 out of 4. In section 2, spinner 2, there was 4 out of 10. So convert those to a percent. So spinner 1 is what percent? 50%. Spinner 2 is 40%. So who has the better chance?
See, I was right.
Good job.
Sometimes it pays to not follow the crowd, right, Caden? Alright, we're gonna come back to number 7 after I dig out and get y'all my pennies so that y'all can actually do that one. Alright, and so look at number 8. Mina opens a book 15 times and records whether the page number is even or odd. How many trials did she conduct? Name 2 events that she recorded. How many trials did she do? Alright, so trials. Basically, how many times did she do it? And then events. What were her events that could happen? Her events were either, remember, an event is what you're looking for. What was she looking for? Even or odd. So Haley, open your book real quick. Where'd you land?
173.
Even or odd? Odd. Alright. Krisha? I don't know, how would you say that? Krisha? Krisha? I don't know. Okay, that girl. Okay, has a bowl with 12 green discs and 8 yellow discs. Is the probability of randomly selecting a green disc unlikely, as not, or likely? Not the way that is said. Is it unlikely, equally likely, or likely? So picking green out of the bag. How would we set that up as a fraction?
12.
How many green we're looking? What are we looking for? We're looking for
12 over 20.
green. So we need green over the total amount. So there's 12 green over a total of how many? There's 12 plus 8, which gives you,
60.
so your percentage is,
60.
and 60% tells us that it is, is it bigger than 50 or less than 50?
Bigger.
So then it is likely to happen. A container holds 20 red, 20 blue, and 10 green marbles. Is the probability of choosing a blue marble greater than or less than the probability of not choosing a blue marble? I want y'all to figure that out. So you got to figure out what is the probability of finding a blue marble, and then what is the probability of not choosing a blue marble. So find those two probabilities and determine, is it better to get a blue or is it better to not get a blue? Blue or not blue? First thing you need to do is figure out the total amount of marbles you have. 20 red, 20 blue, 10 green gives you a total of... Huh? Alright, so what was your percentage for blue?
I got
40.
Okay. How many marbles are not blue?
30.
Well, look at your colors. Red's not blue, right? So 20. Blue is blue, so we can't use that. And there, green is not blue, so there's a total of 30, which is what as a percent?
60%.
Oh, I did something wrong.
So, is choosing blue less than or greater than not choosing blue? Less than. Your biggest thing is going to be reading, looking what it's asking for. Alright, you try number 11 and 12. Alright, describe the probability of each event, likely, unlikely, or equally likely. Then tell us what the percent is, the probability. So we're using words and we're using numbers to figure out that event. Try those two. 11 and 12. Okay? So, roll a number cube greater than 5 on a standard number cube. Well, how many numbers are greater than 5? Because what are your numbers? When you roll a dice, what are your numbers on your dice?
1 through 6.
1, 2, 3, 4, 5, and 6. How many numbers are greater than 5?
1.
Out of a total of? So 1 out of 6 gives me about 17%, which is unlikely. Alright, you pick a number less than or equal to 30 from a bag of 40 pieces of paper that are numbered 1 through 40. How many total options are there? 40. How many of them are less than or equal to 30? If you number 1 through 40, right? How many of them are going to be less than or equal to 30? 30 pieces. And as a percent, that is 75%. And what's the likelihood? Alright. I'm going to do a debate here. Amara has the choice to select a card from pile 1 or from pile 2 without looking. If she selects a yellow card, she wins the game. Which pile should Amara pick from to give her a better chance of winning? Which one do you think is better, just looking at it? Jacob?
2.
Why?
Because there's less cards than the pile 1, and there's a better chance of pulling a lot.
Okay. Alright, there's 2 of every color, so there's better chances. So there's 3, well, there's not 3 of every color.
There's like different
numbers.
Only 3 yellows and 4 of every other color.
Three yellows.
You have less chance of getting a yellow than pile 2.
Alright, so let's do the math to see if you're right. Okay? See if you're going to win. Do the math to see if you're going to win. What is the probability of picking a yellow card here? 3 out of how many? 15, which is what as a percent? Okay. And pile 2, what is the probability of picking yellow for probability, or for yellow, for pile 2? Yeah, there's 2 out of a total of 8, which converts to 25%. So which one is better? So Jacob was right.
And we're gonna start going with short top now.
Huh?
We're gonna start going with short top now.
You think so? You have a better chance?
I guess.
Alright, so on Monday, what we're going to do is, we're actually going to do a few experiment things and let you work on your homework. And then on Tuesday, we'll finish our last lesson, our last brand new lesson of the year.
That's